Dear students, welcome to Quadrilaterals Part 6, Chapter 8 of Class 9 Mathematics book discussion. Dear students, earlier we have learnt about the various properties of parallelogram, rhombus, rectangle, square, etc. Today we are going to discuss about a theorem in which we apply the properties of rectangle, properties of parallelogram, and this theorem is popularly known as midpoint theorem. Let's see what does this midpoint theorem states. The line segment joining the midpoints of two sides of a triangle is parallel to the third side. So, let's visualize this by this figure. Here ABC is a triangle and X and Y are the midpoints of the sides AB and AC respectively. So, what to prove here? Here we join the points XY. So, to prove that XY is parallel to BC. So, how to prove this? To prove this, we need some construction. So, what is the construction here? You see, draw a line through C and which is parallel to AB, and let that meet the extended XY at D. Now, let's prove it. AB is parallel to CD and AC is the transversal. In such case, we have two angles BAC and ACD which are alternate interior angles, so they are equal. Now, you see, in triangle AXY and in triangle YCD, what are equal? We know that angle XAY is equal to angle YCD. Why? Because we have proved that BAC is equal to ACD. Now, AYX and CYD, these two angles are vertically opposite angles, so they are equal. And we have AY equal to CY as Y is the midpoint of AC. So, here we proved that triangle AXY is congruent to triangle CDY. Now, what is the cause of this congruency? This is by angle side angle property. And from this we get AX is equal to CD. We know that AX is equal to BX. Why? Because X is midpoint of AB. So, we proved AX equal to CD and we know that AX is equal to BX. So, BX is equal to CD. Now, in quadrilateral BCDX, you see BX is parallel to CD and BX is equal to CD. We know that if in a quadrilateral the opposite side are parallel and equal, then that quadrilateral is a parallelogram. So, from this we get that BCDX is a parallelogram. If BCDX is a parallelogram, then other pair of opposite sides are also parallel, means XD is parallel to BC. From this, as XY is part of XD, so we can write XY is parallel to BC. So, here we used the property of parallelogram, that is opposite sides of a quadrilateral are equal and parallel, then the quadrilateral is parallelogram. Then what is the converse of this midpoint theorem? The converse of this midpoint theorem states that the line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. That means, in this figure you see, in triangle ABC, X is the midpoint of AB and a line L is drawn through X which is parallel to BC. We have to show that if this line XL intersect AC at Y, then we have to show that Y is midpoint of AC. So, what is to prove? Y is midpoint of AC, that is we can prove that AY is equal to CY. Now you see, here also we need a construction. If you remember the last construction, let's rewrite it again. Draw a line through C parallel to AB and let it intersect this extended XY or the line L at D. Then how to prove? In quadrilateral BC DX, we have BX is parallel to CD, it is construction, and XD is parallel to BC, it is given. So, as in this quadrilateral, the opposite sides are parallel, so this is a parallelogram. As this is a parallelogram, so opposite sides are also equal. From this we can say that BX is equal to CD. Now, AX is equal to BX, it is given as X is the midpoint. So, from these two equations, that BX equal to CD and AX equal to BX, we can conclude that AX is equal to CD. If AX equal to CD, let's try to prove the congruency of triangle AXY and CYD. So, in triangle AXY and triangle YCD, AX is equal to CD, AXY is equal to CDY. These are alternate interior angles, as AB and CD are parallel and XD is the transversal. Now, AYX and CYD, these two are vertically opposite angles, so they are equal. Now, we have proved that these two triangles AXY is congruent to triangle CDY. By which property? By angle side congruency, this is proved. Now you see, if these two triangles are congruent, then we can say that AY is equal to CY. That means it is the AC is bisected at Y, that means XY bisects AC. Now, let's see the application of this theorem. This question is, ABCD is a rhombus and P, Q, R and S are the midpoints of sides AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is a rectangle. So, here it is given that ABCD is a rhombus, P is midpoint of AB, Q is midpoint of BC, R is midpoint of CD and S is midpoint of AD. So, if we join PQ, QR, RS and PS, then we have to prove that PQRS is a rectangle. So, to prove here, we have to prove that PQRS is a rectangle. So, before proving this to be a rectangle, first let's prove it to be a parallelogram. So, join BD. If we join BD, so one construction here, that is, draw BD. Now see, first part of the proof, let's see. In triangle ADB, S and P are midpoints of sides AD and AB respectively. S is midpoint of AD and P is midpoint of AB. This implies that SP is parallel to DB or BD. Similarly, we can take another triangle. In triangle BCD, Q and R are the midpoints of CD and BC respectively. This shows that RQ is parallel to BD. Again, if we consider another part of the midpoint theorem, which may state that this line SP is half of the side BD, so we can write that SP is equal to half of BD here, and also we can say RQ is equal to half of BD. Now from this 1 and 2 we can conclude that this SP is equal to RQ. Now in triangle, now in quadrilateral, S, P, Q, R, we have SP is parallel to RQ and SP is equal to RQ. This shows that PQ RS is a parallelogram. Now second part says that to prove this parallelogram to be a rectangle, we have to show that each angle is 90 degree or the diagonals PR and SQ are equal. Let's try with the diagonals. For that, the second construction here is draw the line segments PR and SQ. Now, here you see in quadrilateral APRD AP is equal to RD. Why? Because AB equal to CD. As AP is midpoint of AB. So half of AB is equal to half of CD, that is AP equal to DR. Also, as this is a rhombus, rhombus is a parallelogram, so opposite sides are parallel. So we can say AP is parallel to RD. That shows that AP RD is a parallelogram. APRD is a parallelogram which says that AD is equal to PR. Similarly, in quadrilateral, ASQB, AS is equal to BQ as AD is equal to BC. Also, AS is parallel to BQ as these two are. AD is parallel to BC as they are opposite sides of parallelogram, that is rhombus. So this shows that ASQB is a parallelogram and this shows as ASQB is a parallelogram, so SQ is equal to DC. Now we know that ABC, AB, BC, CD, DA, all four are equal. So from equation this 3 and equation 4, you see AD is equal to CD, so PR equal to SQ. So we can write from equation 3 and 4, we get that CD is equal to PR. SQ is equal to PR. So in quadrilateral, in parallelogram, PQRS in parallelogram PQRS, diagonals SQ is equal to PR. This implies PQRS is a rectangle. So thus we proved this theorem, this question by applying the midpoint theorem. See, we can have some extension of this theorem like this. We know that triangle AXY is congruent to triangle CDY as it is given. So from this we can say that XY is equal to YD. Now we know that BXDC is a parallelogram From this we get that BC is equal to XD. And what is XD? XD is equal to XY plus YD. And we know that XY is equal to YD. So we can say that XY in place of YD we can write XY. So this shows that BC is equal to 2XY, or XY is half of BC. So we can further extend this theorem like this. If the line segment joining the midpoint of two sides of a triangle is parallel to the third side and its length is half of the third side. We proved here that XY is half of BC. So this line segment joining the midpoints is half of the third side. Let's see another question. The question is, ABCD is a rectangle and P, Q, R and S are midpoints of the sides AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is a rhombus. So here given that ABCD is a rectangle, P is midpoint of AB, Q is midpoint of BC, R is midpoint of CD and S is midpoint of AD. We have to show that P, Q, R, S is a rhombus. So to show that this is a rhombus, we have to prove that all the sides are equal. So to prove PQRS is a rhombus. Now let's have some construction. What is construction here? We have to draw the diagonals AC and BD. Now draw diagonals AC and BD. Now see, in triangle ABC, P and Q are midpoints of AB and BC respectively. This shows that PQ is equal to half of AC. Also, and PQ is parallel to AC. In next ADC triangle, in triangle ADC, R and S are midpoints of CD and AD respectively. These two are midpoints. This shows that RS is equal to half of AC and RS is equal to RS is parallel to AC. From this condition 1 and condition 2, we can conclude that from condition 1 and 2, we can conclude that PQRS is a parallelogram. Now, again, in triangle ADB, P and S are midpoints of AB and AD respectively. This implies PS is parallel to BD and PS equal to half BD. Again, in triangle CDB, Q and R are midpoints of BC and CD respectively. This shows that QR is equal to half BD and QR is parallel to BD. PS equal to half BD, QR equal to half BD. Here PQ is equal to half AC and RS is equal to half AC. So as ABCD is a rectangle, so AC is equal to BD. So from equation 1, 2 and here it is 3 and 4, we get as AC equal to BD, so half of AC equal to half of BD, and as we proved that PQ equal to RS is equal to half AC and half AC equal to half BD and half BD is equal to PS and RQ. So we can say that PQRS is a rhombus. So here we proved this question by applying the midpoint theorem. Let's have another question. The question is, show that the line segment joining the midpoints of the opposite sides of a quadrilateral bisect each other. So here any quadrilateral is given, say ABCD. The midpoints of AB, the midpoint of AB is P, BC is Q, and that of CD is R, and that of AD is S. We have to show that SQ and PR bisect each other. So given in quadrilateral ABCD, P, Q, R and S are midpoints of AB, BC, CD and AD respectively. We have to show that to prove that PR and SQ bisect each other. So, to prove this, let's complete this quadrilateral PQ, QR, RS and PS and join AC. So, draw PQ, QR, RS, SP and AC. You see, in triangle ABC, we have P and Q are midpoints of AB and AC, which shows PQ is parallel to AC and PQ is equal to half of AC. Similarly, in triangle ADC, in triangle ADC, S and R are midpoints of side AD and CD respectively. This shows that SR is parallel to AC and SR is equal to half of AC. Now see, here PQ is half of AC and SR is also half of AC. That means PQ is equal to SR. Again, PQ is parallel to AC and SR is parallel to AC. So, PQ is parallel to SR. So, we can name these two conditions as 1 and 2. So, from conditions 1 and 2, we conclude that PQRS is a parallelogram. And we know that the diagonals of parallelogram bisect each other as PR and SQ are diagonals of parallelogram PQRS. This implies PR and SQ bisect each other. So here again we proved this statement by using the midpoint theorem. Dear student, we discussed in this whole chapter of quadrilateral about various properties of parallelogram, and one of the best application, that is midpoint theorem. And using this midpoint theorem, we also solved various problems, and I hope this will helpful to you. Have a good day. Thank you.